In this lecture, I am going to discuss about Laplace transform and the importance of the Laplace transform. Or you can say, what is the need of the Laplace transform? These two things I will discuss in this lecture. And first I am going to discuss about the importance of the Laplace transform, about the need of the Laplace transform. First thing, Laplace transform is found very suitable uh, to solve a differential equation. You can solve the differential equation easily through the Laplace transform. However, the classical method of solving differential equation is very important for understanding the fundamental concept of the differential equation and their solution. Also, this method of solving differential equation is required where transformation method is failed. But when differential equation has a function and that function has point of discontinuity or their derivative has point of discontinuity, then it is very hard to apply classical method to solve such differential equation. In such case, Laplace transform method is found suitable. So through the Laplace transform, you can handle such a function which has point of discontinuity or function derivative has point of discontinuity. The second importance fact of the Laplace transform is you can easily get the transform of exponential function which are frequently occurring in the mathematical modeling. So you can easily get the transform of such function which has exponential function. And the third merits of the Laplace transform is the Laplace transform has ability to transform non-sinusoidal periodic function. You can easily transform the periodic function which is non-sinusoidal in nature. So this is the, uh, you can say, this is the one of the main merits of the Laplace transform. And also Laplace transform has ability to change differential equation and integration in forms of multiplication and division, and then it is easy to handle such function. Just you have to transform differential equation and integration. You will have to obtain Laplace transform of differential equation and integration. You will found that differential equation and integration will be converted in terms of multiplication and division, and then you can easily handle a mathematical operation. Further, the estimation of constant in differential equation, when you will solve the differential equation through the classical approach, then you will have to determine natural component and forced component. And the complete solution will be the sum of natural component, or you can say homogeneous component and the forced component. And while you will solve the uh, while you will try to obtain the complete solution of the any differential equation through classical approach, then you will have to find uh, constant, and this constant is estimated through initial condition. So everything you already studied in previous classes. So the estimation of constant through the classical approach, when you will solve the differential equation through the classical approach, then you will have to determine the constant. And the estimation of this constant is very hard through the classical approach. You will have to apply initial conditions. But when you will solve the differential equation through the Laplace transform method, then the solution which you will obtain through the Laplace transform method will be complete, and there will be no need of estimation of any constant if you will solve the differential equation through Laplace transform. So these are the merits of the Laplace transform, and you can say these facts uh, represents the need of the Laplace transform. What is the need of the Laplace transform? The basically Laplace transform is used to solve the differential equation. And addition to this merit, capability of solving differential equation easily, in addition to this merit, Laplace transform has other various merits also. And In next slide, you will see the Laplace transform of all the function is not possible. Sorry, Fourier transform of all the function is not possible. When you will try to find the Fourier transform of unit step function, then you will not get any meaningful result. When you will solve when you will try to find the Fourier transform of sinusoidal signal, you will not get any meaningful result. And these two signals are very important. And its transform, its representation in frequency domain is very important. So you can say, in conclusion, you can say, you cannot get the Fourier transform of all the function. So there is a need of a transform which is applicable for all the function. So these are the merits and that represent the need of Laplace transform. Now, how you will get Laplace transform from Fourier transform? Laplace transform is actually the limiting approach of the Fourier transform. When you will apply certain limiting condition on Fourier transform, you will get the Laplace transform. So you can say the Laplace transform is a limiting approach of Fourier transform. As I have stated you earlier, Fourier transform of all the signal is not possible. For instance, if you will find Fourier transform of unit step signal, you this Fourier transform does not give any meaningful result. So what will be the Fourier transform of in previous lecture I have already discussed Fourier transform of any signal xt is basically will be a function of frequency, and it is given as minus infinity to plus infinity xt e to the power minus j omega t. And if you will change the lower limit from minus infinity to 0, if you will change this lower limit from minus infinity to 0, then such Fourier transform is called unilateral Fourier transform. This is unilateral Fourier transform. And in practice, we need not to be concerned about negative value of t, because we would be interested in the response of the system only after the application of excitation. So you can ignore the negative part of the signal and you can start analysis from 0. But when you will start analysis from 0, then such Fourier transform will be unilateral Fourier transform. So now the question is, what will be the Fourier transform of ut? So in place of xt, you will have to write ut here, e to the power minus j omega t. And in between 0 to infinity, ut will be 1. So this become equal to e to the power minus j omega t dt. And when you will integrate this term, you will get this result. And now e to the power minus j omega t is cos omega t minus j sin omega t. And what will be the value of cos omega t when t is infinite? What will be the value of sin omega t when t is infinite? What will be the value of cos omega t when t tending to infinity? Its value will be undefined. Similarly, what will be the value of sin omega t when t tending to infinity? It is undefined. So the spectrum of unit step signal, or you can say the Fourier transform of unit step signal, is undefined. You cannot get the Fourier transform of unit step signal through this formula. So to solve to get frequency spectrum of meaningful frequency spectrum of unit step signal, some limiting approach is required. Without this, you cannot get the meaningful result of such type of function. Similarly, when you will try to find Fourier transform of sinusoidal signal, then Fourier transform, then the result will be also not meaningful. So for solving such type of signal, or for getting frequency spectrum of such type of signal, some limiting approach is required. So Laplace transform is just a limiting approach of Fourier transform. What will you do to get Fourier transform of this signal? Just you will have to uh, get Fourier transform of this signal, ut e to the power minus sigma t, and in answer you just take sigma tending to 0. As you will take sigma tending to 0, obviously this become the Fourier transform of ut. So how you will solve Fourier transform of ut? So not directly you can solve the Fourier transform of ut. You will have to determine Fourier transform of ut into exponential to the power minus sigma t. And finally, in the final result, you will have to take sigma tending to 0. In this way, you can get the Fourier transform of ut. So what will be the Fourier transform of ut? E to the power minus sigma t. So in place of xt, you will have to write ut to the power minus sigma t. And you must remember this is unilateral Fourier transform, because lower limit is 0, and we are not interested in the negative value of t, because uh, we can start analysis only after the application of excitation. So in place of xt, you will have to write ut to the power minus sigma t into e to the power minus j omega t dt. This is xt. Xt e to the power minus j omega t dt will be x omega. So in place of xt, you will have to write ut e to the power minus sigma t. And now power will be added together. You will get this term. And this is a complex number. This is not a vector. E to the power minus j omega t is a vector. But e to the power minus zt, where z is the complex number, is not a vector. Complex number is a number. So after integration, you will get this 1 by sigma plus j omega. And when you will take sigma tends to 0, when you will put sigma plus j omega equal to s, then this x omega become xs, and this become 1 by s. And when you will take sigma tends to 0, then this xs is called Laplace transform of ut. So this is basically a Fourier transform. Laplace transform is basically a Fourier transform, but there is a limiting condition. In this case, uh, you will have to multiply function with a factor which is called converging factor. E to the power minus sigma t is the converging factor. By using this converging factor, first you will have to determine Fourier transform, and through this limiting approach, you can get the Laplace transform. So this is the way through which you can get Laplace transform of any function. For example, you want to determine uh, Fourier transform of signal ft. Suppose you want to determine Fourier Fourier transform of signal ft, and this ft is not differentiable, not integrable. Then how can you determine the Fourier transform of this signal? So first you will have to determine Fourier transform of ft e to the power minus sigma t. And you must remember this is converging factor. And what will be the Fourier transform of this signal? So in place of xt, you will have to write ft to the power minus sigma t e to the power minus j omega t dt. This is unilateral Fourier transform of signal ft e to the power minus sigma t. And you will get frequency. You will get a spectrum of ft to the power minus sigma t. And then what you will do? Let us consider this sigma plus j omega is s. And sigma tending to 0. As you will take sigma tending to 0, this Fourier transform is termed as the Laplace transform. It becomes Laplace transform. So when you will put sigma plus j omega equal to s, then this x omega become xs. And when you will take sigma tending to 0, real part of the complex number is very small when you will assume, then this Fourier transform is called Laplace transform. So this is the Laplace transform of any signal xt or any signal ft. So this is the formula through which you can get the Laplace transform of any signal. Here you must remember e to the power minus sigma t is converging factor, and at last this factor will be equal to 1 because you will have to take sigma tending to 0. So what will be the definition of Laplace transform of any signal? So if you want to determine Laplace transform of any signal xt, then this will be equal to 0 to infinity xt e to the power minus st dt. This is the definition. Suppose you want to determine Laplace transform of ut, then in place of xt you will have to write ut. Suppose you want to determine Laplace transform of sine omega t, then in place of xt you will have to write sine omega t here. So in this way you can determine the Laplace transform of any signal. But you must remember here s is equal to minus sigma is equal to sigma plus j omega, sorry. S is equal to not minus sigma, it is sigma plus j omega with sigma tending to 0. So in this way, the signal for which Laplace transform is not possible, you can get, for the signal for which Fourier transform is not possible, you can get its Laplace transform by this limiting approach. And this is called the Laplace transform of a signal. So in next lecture, I will discuss Laplace transform of some important signal and the various application of Laplace transform.